The NX CAE Multiphysics environment helps you to more easily tackle complex simulation, such as blade clearance analysis within aircraft engine systems, as you'll see in this example. Here we're looking at the geometry for the compressor section of an aircraft engine. An engineering analysis for these kinds of models are typically done on a two-dimensional slice of the geometry, which we can easily create through the integration with NX CAD. The engineer begins by setting up the analysis in NX CAE to use the NX Multiphysics environment for a coupled thermal structural analysis. Then the engineer begins meshing the cross-section geometry. Since this is a 2D model that's revolved around the horizontal axis, the engineer uses axisymmetric elements to represent the discs and casing, and plane stress elements for the blades. Since this is a transient analysis, where the engine passes through a mission profile such as takeoff, cruise, and landing, NX CAE can help the engineer to easily set up the various condition sequence parameters that will affect the engine at each stage of the flight. Setting up boundary conditions for such complex models can be a challenge with traditional tools, but NX CAE helps to simplify the process with advanced thermal boundary condition commands that can reduce definition time by up to 75%. The engineer can even use expressions to define interdependent boundary conditions, which can even be evaluated at solve time. With the analysis model defined, the engineer then kicks off the solve, and the solution monitor will simultaneously track solution progress for the coupled structural thermal solution between NX Nastran and NX Thermal. The engineer can view graphs to monitor convergence for both the thermal and structural solutions, and he can also monitor the progress of key results. Post-processing of the results in NX CAE then allows the engineer to understand deformation and temperature of the compressor at various stages of their mission profile. And new result probe capabilities in NX CAE provide the ability to use powerful expressions to create new, measurable result types. In this case, the engineer creates a result probe to assess and graph blade tip clearance between the engine blade and outside casing. NX CAE, delivering an efficient, integrated workflow to perform complex multiphysics analyses.